We've got another set of videos here now for this new lesson. And this new lesson, again, I'm not really going to be showing you anything new in these 4 videos. What I am going to be showing you is I'm going to be kind of decomposing some things that you've already been doing, but we're going to go at them from the back end. So it's that whole backwards kind of thing that we're going after here. So we're going to start with, and the name of the lesson is Factoring Special Products. We're going to start with difference of squares. So you got to remember what difference of squares are. So a difference of a square is anything where you wind up with 2 terms. It's a difference, so there's going to be a subtraction sign in the middle. All right, and then your first, and you only have 2 terms after you multiply it out. Your first and your second term, so both of your terms are both going to be square numbers and or square variables. So remember, when we talk about square variables, it has to be an even exponent. So x squared would be a square variable, x to the 4th power, x to the 6th power, anything with an even exponent. And then with a square number as a coefficient, or just a square number by itself. So 4, 9, 16, 81, 121, 144, 169, any of those. So let's take a look at some of these, and we're going to talk about identifying them. Now, the first thing I want to talk to you about is what happens basically. So these should look kind of familiar, right? And if we work on one of these, right, when you multiply these out, right, as I'm doing here, plus 3x, and then minus 9. Remember what happened is these 2 terms cancel each other out, and that's how you wind up with your difference of a square. So when you factor it and you go backwards, basically what you're doing is you're taking this, and you're taking that, and you're taking the square of those, and they're both going in to your binomial brackets, and then one of them is going to be negative, and one's going to be positive. And so same thing with this one right here. If I multiply this out, and I shouldn't have to go through this every time, because I should be able to recognize that this is a difference of squares and just go, okay, just square this number, and put a minus sign between them. And so I get that. Okay, so quick little review on that. You recognize if the polynomial is a difference of squares. So first of all, there'll be 2 terms, all right? And usually almost only 2 terms. All right, both terms will have square coefficients. And remember, if it's just a variable, and there's no coefficient listed, that means it has a coefficient of 1. So they'll have square coefficients. So any number in front of it, either listed or not listed, is going to be a square number. And then the variables will be even. All right, even exponents. All right, they'll have even exponents. I wrote that kind of awkwardly, but I think you get what I'm driving at. So let's take a look at some of these. Determine whether the polynomial is a difference of squares. If so, factor it. Well, we've got 2 terms, so it meets that criteria. This is a square number, and then the number that's not listed here, which is 1, is a square number. So we've got our 2 square numbers, and then my variable is square. So yes, this is a difference of squares. All right, and so that means that basically what you do is take the square root of this and take the square root of that, and those are going to go for your terms. So square root of 81 is 9, so 9 is going to go right there, and the square root of c squared is c, and then you're just going to have a minus and a plus, or a plus and minus. It doesn't matter. All right, let's look at the next one. Okay, so first things first. Look at your coefficients. We've got 2 terms, so it meets that. Look at your coefficients. Well, this is square root of 36 is 6, so that's good. 27, however, is not a square number. All right, it's very close to a square number. It's very close to 25. It is a cube number, but it is not a square number. So right away, that should tell you no way, because there is no number I can multiply by itself that's going to be, rational, that's going to work for that. Okay? All right, next, let's take a look at this guy right here. So 25y squared plus 1. Well, here's the thing. Square number, so that's good. And then our variable has an even exponent, so that's good. But it's missing something really important. And what it's missing is it's missing a minus sign. It's a difference of squares. It's not a sum of squares. It's a difference of squares. Because there's nothing I can do to this to figure that out and to get that to solve. Right? So that's not going to work for us. So this would be no. All right, so we've got a couple no's. Now let's take a look at this last one. We got 64 and 1. So the square root of 64 is 8. Square root of 1 is 1. So that's good. And then both of our exponents for our two variables, and you can have, two variables in these. You can have multiple variables in them, but they all have to be even exponents. All right, they all have to have even exponents. So this works, right? So you just figure out what's the square root. Let me get rid of some of this nonsense. So figure out what's the square root of 64g squared. Well, it's 8g. Right? Because 8g times 8g is 64g squared. And then you say, okay, well, what's the square root of h squared? Well, it's h. Right? Because h times h is h squared. And then you put your plus and your minus, and you're good to go. All right? So that's pretty much how these work. Recognizing them and then just remembering how to kind of factor them out. And then once you know what signs to look for and you get a little better at it, these are going to go really quickly.